Okay, technical problem solved. Good afternoon, everyone. Welcome back for lunch. Hope you had a nice one. I'm Dave Knight from Newstar. I'm on the OARC program committee. I'm going to be chairing this session. Announcements. I think the Lightning Talk submissions are now closed. And the OARC 32 survey is up, and the link for that is on the OARC 32 website. And so let's move straight on. First up this afternoon, we have Evan Hunt from ISC, who's going to talk to us about Bind 9. Evan.
Hello, everybody. I'm Evan. I'm one of the senior developers on Bind 9 at ISC. Actually, just passed a weird milestone a couple of weeks ago. I noticed on the calendar that as of January 27th, I think I've worked on Bind for more than 1/4 of my life, which no doubt gives me a really skewed and broken perspective on it. But I was asked to give a talk about some of the newer things that we've been doing recently. And first things first, the new stable branch is Bind 9.16. The 0.0 is supposed to be out in a couple of weeks. It was supposed to be out a couple of months ago. We had to delay it twice, but this time for sure. Major new features, we have a new networking system that's more efficient. We have DNS-OARC key and signing policy support, and we've obsoleted DLV, and I'm going to be talking about those things in more detail. So because of the skewed and broken perspective, I asked on Twitter a few weeks ago, asked Bind users what they thought that we were doing right and what we were doing wrong. And I got 12 or 15 answers. I'd still like more. There's my contact information if you want to weigh in or see me in the hallway. Some of the nice things that they said were RFC conformance, versatile, it can be recursive, authoritative, forward, or whatever. It's familiar, it's everywhere. Tools were good, documentation was good. I have to admit that surprised me, but people said it. And professional support availability. So that's nice, good to hear. The things that people said were less good. Too many features and not enough features I'm just going to cancel algebraically. Apparently we're doing that right. There were complaints about too many configuration options. Somebody complained that the configuration uses file editing as its mode of operation, and I wasn't entirely able to nail down what he hoped it would be instead, but I'm guessing asking for an API of some kind. Somebody commented that development is slow due to a complex code base, which was really insightful and really accurate. And a dog that didn't bark is nobody said performance, which surprised me a lot because that's a thing we think about a lot. I don't know if it's actually good enough for most uses or if the people that were answering my poll just have moved on to use other servers because it's not fast enough. But anyway, these things provide a nice little list of things that I want to discuss today because it turns out that all three of those things are things that we've worked on in the 9.16 time frame. So gives me a nice framework to discuss the subjects that were coming up, almost as if I'd planned it that way. So highlighting on configuration, one particular thing that has been a burr under a lot of people's saddles for a long time has been DNS-OARC configuration. It is a great deal better than it used to be. It used to be nearly impossible. And we have added smart signing and key maintenance and the DNS-OARC key manager tool, which can implement a key and signing policy and an offline cron script. We've added inline signing. There are a lot of things that we've done, but it is still a lot of moving parts. It's complex. There's a lot that has to be done outside of named. And so we did some things to simplify DNS-OARC configuration. The first couple are just trivia, really. DLV is obsolete now. If you were here at in San Jose for the OARC in September of 2017, you got to see isc.dlv.org turned off. Thank you. Brain glitch, sorry. After that, we removed automatic DLV configuration in Bind. We kept manual DLV configuration available because we thought it might be useful to some people, and then we determined that it really isn't. So in this release, we've taken it all out. The option doesn't do anything except for a little voice saying, please don't push this button. And all of the relevant code has been removed from the validator. We have updated the way trust anchors are configured. Most people aren't going to see this or notice it because validation from the root is turned on by default. However, if you configure your own trust anchors, the trusted keys and managed keys statements are deprecated now. They're being replaced with a single trust anchors statement, which uses a similar but not identical syntax. Trust anchors let you set both static or initializing keys. Initializing ones are ones that are going to be maintained by RFC 5011, and static stay there permanently. You can use either DNS key or DS format. DS format is new. Supporting DS format trust anchors meant that we could reduce one of the code paths in the validator because we don't need to validate keys against DNS key trust anchors anymore. We can just use the same code that we use for validating DNS keys against the parent DSRR set. So the validator has been shrunk by several hundred lines of code, and the McCabe complexity is down by about a third. So this is the big Megillah. Key and signing policies are a thing that have been around for quite a while in OpenDNSSEC. It's a mechanism for defining how you want your zone to be signed, and then it gets kept up automatically. We have this now in named with the new DNSSEC policy statement, which allows you to specify how many keys you want generated for the zone, what roles you want them to play, what algorithms you want them to have, what lifetimes you want them to have, and various other options. Roles are fully automatable within named. Named generates its own keys. Nothing has to be done in an offline cron script. We're not able to fully automate the rolling of KSKs yet because you still have to submit the DS upstream, but everything else should work. These were the signing options that you could use before CASP. Not really a very realistic list. Most of those have perfectly useful defaults, and you wouldn't actually have to configure them. But in a typical case, you'd have at least those two, and you would have to have an offline script that was generating and maintaining your keys, or you would generate keys once and then never roll them at all. I just said what was already on this. Yeah, these things can be automated. DNSSEC Key Manager does a pretty good job, but it does require another moving part separate from named. Nowadays, you can just set a DNSSEC policy of default, which will give you a reasonable default, single combined signing key, ECDSA 256 algorithm, unlimited lifetime. If you want to be a little bit more cautious about it, then you set your own DNSSEC policy and then specify that in the zone. This one gives you a separate ZSK and KSK. The KSK never rolls over. The ZSK rolls once a year. When a key reaches the end of its lifetime and a new key needs to exist, that key will just come to exist. Named will make it. Auto DNSSEC and inline signing are now implicit. State transitions from one key to another are monitored so that illegal changes don't happen. If the key lifetime is so short that zone TTLs would not expire before the key had expired, causing validation failures due to cached obsolete RRSIGs, then the key's lifetime will just automatically be extended to cover that. So it will roll at the right time. To get into some of the weeds of how it works, every key has a state machine of 4 states that it can be in. When it is first brought into existence, it is not yet published, it's hidden. It then moves into a rumored state, meaning that it has been published. Some caches have seen it, some of the secondaries have seen it, some or all of the secondaries have seen it. At the point when it's available to every cache, it's on all of the secondaries, it becomes omnipresent, and it stays there until it gets ready to retire, at which point it becomes unretentive. Some other key is moving from hidden into a rumored state. This key is no longer published, and it's expiring from caches. And at the point when it is fully expired from cache, then it becomes hidden again, and it can be purged. I put this in just because I think it's awesome. This is Uri Schaefer's algorithm to ensure that the chain of trust is valid. It's 3 rules. 1 is that there has to be a DS published for your zone. 2 is that the DNS keys have to match. There's 4 separate rules there articulated in complex logic. And the 3rd one is that all the records have to be signed by at least 1 key of each algorithm that's visible to all validators. And I just love that. So anyway, The way it's implemented is that every key that you generate now has a third file associated with it. If you're familiar with the keys that Bind uses now, there are two files. There's a key file and a private file. We have stored metadata for a long time about when the key is supposed to roll, to be activated, published, deactivated, unpublished. That information was stored in the private file, which turned out to be a design error on my part, because the private file can't be publicly readable, and sometimes it's necessary for something that doesn't have access to the private key material to know when a key is scheduled to expire. So that was a problem. So what we have now is a state file, which contains all of the same information, plus some more information about the state of the key, indicating what the key's successor is, what its lifetime is, so on. It's accessible from outside of the named user. The old metadata that used to live in the private file is also in the state file, so you can get it, but it's still in the private file for legacy reasons, so old tools still work. This is what a state file looks like if you're curious. This is for a key signing key. It's a combined signing key, actually. You can see it's got information about the state the key is in, the scheduled changes, and what its goal state is. And here's one for a ZSK. It's shorter because it doesn't have the information about DS. Things that aren't working yet. You can't configure NSEC3 yet. That shouldn't be too hard to do, but we haven't had time. Querying the parent to monitor the DS status prior to a KSK rollover would be nice. I'd like it so that we can submit a DS upstream, but be sure that the rollover won't occur until we've actually seen it happen. I'd also like to have a mechanism to signal named that the DS has been submitted so that we don't initiate the roll before it's ready. Currently, you just have to know when the KSK is going to roll. You have to submit the DS at about the right time and hope everything works. So that's coming soon, but it's not fully there yet. We need better monitoring via RNDC or some other mechanism. We need a way to purge keys automatically, and we would really like to have support for CDS or CDNS keys so that parents can pick up DS changes without human intervention at all. Moving along the subject of slow development due to a complex code base. What are we doing about that? So why is it that way in the first place? Bind is 21 years old. It had a number of architectural design goals back in 1999 when the team first started working on it. Hardware at that time was not all multiprocessor. Single processor hardware was more common. There were a lot of operating systems still in use that didn't have any thread support at all. And Bind wanted to run everywhere. So it was designed with this sort of bifurcated architecture where it can be both threaded or not threaded depending on how you compile it. And not being able to rely on operating systems for some services that we all take for granted now, like good memory management or socket and event libraries, Bind wrote its own. None of it's optimized for modern hardware, obviously. And over the 21 years that we've been developing it, we've added lots and lots of new capabilities and rarely removed old ones. Last week, Vicky Risk pinged me and said, hey, do you need like an architectural diagram of Bind for your talk? Here, use this one. It's disturbing how good a metaphor that is. It's also available as a laptop sticker. See me after. So what we're doing about it, one thing that we're doing about it is we invented a new network API in this cycle. Witold Prantitki did most of the work on this. I hope I pronounced that correctly. It was a best effort, Witold. I'm sorry if I missed it. There is a new socket API which is based on libuv, which is called, stands for Unicorn Velociraptor, and it's an open source socket and asynchronous networking and event library. It's designed for flexibility. If we need to remove libuv and use something else instead, we can do that without too much pain. The design in general is a lot more efficient, requiring fewer context switches and less thread synchronization. And one of the main goals for it was to address the problem that it was going to be a huge headache to start supporting new transports such as DOT and DOE. The way we've built it so far, we've redesigned the query processing logic so that it no longer needs to know what transport a query came over. DNS over UDP and DNS over TCP are very similar but not identical. There's a length field that goes at the beginning on TCP. So we have query processing logic that gets a message. When it is read in through the UDP net manager module, the message is just passed along intact. When it's read in through the TCP module, it gets passed along to another module stacked on top of that, which strips off the length field at the beginning, so that the query that arrives doesn't have that field, and we don't have to know about it. It's a fairly simple problem to solve, but we're solving it in a new way here. And the advantage of having a design like that is that next year we can write 2 new modules that sit on top of TCP and translate to TLS or HTTPS, and we'll get DOT and DOE. And while we haven't done the work yet, we have tried to do the work on TLS a few times already. We have 2 abortive branches that were abandoned because it just got too hairy. So this is I'm optimistic about this change. And I want to talk about performance because that was the other big goal with the network manager. The socket API that we were using involved lots of context switches. We had optimistic hopes that getting rid of that bottleneck by switching to the new network manager would improve performance, and initially it didn't pay off that much. We've seen a slow increase in authoritative performance from 9.11 to 9.14 to 9.16.0. Recursive performance is about the same. However, it turns out that when you remove one bottleneck, the bottlenecks that were still there downstream are easier to see and profile, and some of them turn out to be relatively easy to fix. So we have a branch in development for the 9.16.1 release, which will be coming out in March. And these are the results we're seeing in that one. Over 1 million queries per second on hardware that was previously getting about 700,000. Recursive, similarly better. We're actually getting within about 5% into the ballpark of not DNS on the same hardware, which is gratifying to me, although apparently not has now tripled their performance with this XDP thing, so that's irritating. But anyway, the problem still is that we've only had time to do this for processing of incoming client requests. The network manager, the socket API is used for lots more things than that, and we haven't had time to convert any of the other stuff. So right now, Bind still has 2 network APIs, and if we don't do something about that, someday we might have 3. Let's not go there. So high priority work in the 9.18 development cycle is going to be completing the conversion from ISC socket to the net manager. Implementing net manager modules for DNS over TLS, implementing and DNS over HTTPS, and adding more DNSSEC policy features, as I discussed before. And that's pretty much it from me. Questions?
Robert Evans. Have you removed all the assembly code yet?
I think we have, yeah.
Yes, that's all gone from 9.14.
Yeah, we're using less and less homegrown stuff. We're not going to be using homegrown locks anymore, and we no longer use homegrown atomics at all. And that's where most of the assembly code was.
Paul Hoffman. So I've been looking at, first, thank you very much on the DNSSEC stuff. I've been looking at some of the documentation in the 9.15. Automation looks great.
By the way, I stumbled over and failed to mention that most of that was implemented by Matthijs Mekking. I don't want to take any credit away from him. Okay. He did an awesome job.
Well, I mean, when I say you, there's a lot of yous here that are all
I just remembered I'd forgotten to say his name out loud, and I wanted to fix that.
But related to that is something which I'm hoping everyone in the room, including you, are looking at, which is how to explain to users how to do algorithm changes. The SHA-1 stuff that happened last year, the beginning of this year, has convinced a lot of us that we should be encouraging people to change their signing algorithms, and less importantly, but still changing their DS algorithms.
Thank you very much for mentioning that, because I forgot to say that. The way you roll algorithms with the DNSSEC policy is you change the algorithm in your DNSSEC policy.
Yep.
And it will
I
generate...
thought that's what I saw from your documentation.
It will generate new keys with a new policy. It will expire the old ones out when they were scheduled to expire, and it will just work, except if you have a key rollover in process at the time that you do this, you're going to have problems. It's not working yet.
Right. So I'm hoping that you will document that reasonably well, because I think we're going to see a lot of algorithm rollovers this year. ICANN separately are going to be encouraging TLD operators who are signing with SHA-1 to change, and sort of we're going to be doing a lot of publicity. So I'm actually asking this to everyone in the room who has any signing software. Please consider having a simple standalone guide like we did a couple of years ago for how to change the KSK, for how to roll from SHA-1 to something sane, because we're going to be doing a bunch of publicity on it. I think it would be useful for everyone. And again, I'm very happy with what I've seen in 9.15 of what you've done. But a standalone, how to go from signing with SHA-1 to something else, I think will be of a lot of use
First,
this
I think
year.
we're going to have to fix some bugs in the process, because if you happen to have a key rollover going on when you add a new algorithm, the results are going to be unexpected.
Right.
So I think that's going to need some work, but yeah, documenting it is a good idea. That's not my wheelhouse, really. I hope I can get some help from some good writers.
Great.
But
Okay,
anyways,
thank you.
Thank you for your kind words.
Yep.
Hello,
Just a
Tel.
quick follow-up on that. You said if you're going to have problems if you already have the key rollover in progress.
If a key rollover is currently happening.
Right. I don't doubt it, that
Yeah.
might cause problems, but you could presumably put a block in it that says, I'm sorry, you can't do that now.
That might be how we solve the problem, yes.
So, that's all.
Brian Dixon, GoDaddy. I've been doing stuff with DOT very recently. Very encouraged to see you guys doing the DOT in 9.17. Quick request is please support certificate validation through DANE, not just Web PKI for the DOT. And also make sure, I'm presuming it's going to be both on the client and server side.
I'm sorry. Client side is what I expect that we will be supporting.
Okay.
Initially, at least, we'll be supporting client requests via TLS. I don't know if we'll be doing X for over TLS or anything initially.
Okay, I was thinking in the forwarder mode.
Oh, I'm not sure.
Okay, thanks.
Hi, Tel. So I feel like a film grad student in that this isn't a question so much as I just wanted to make a comment. I wanted to just provide a little, for the room, a little historical context on something that I appreciate very, very much, how much effort you're going through to simplify these aspects of like the network interface stack and all that. The historical context, I think, is relevant, though, because Bind has often been a sort, kind of targeted with derision for how complicated that particular layer was. What's really important to recognize is that Bob Halley, as the principal architect, I thought did a fantastic job with designing that system with the constraints that were in place at the time. With, after Paul got funding to rewrite Bind 9 from the ground up, this consortium of Unix vendors had a number of constraints about how they needed to highlight their micro-threading architecture and how we had to run on several different platforms and needed that compatibility layer that ultimately, I think that given all of the restrictions that were placed on how it was going to be implemented, that Bind 9 actually turned out to be quite fantastic, given the number of different obstacles that were put in its place as far as its
I
design
wholeheartedly agree
constraints.
with you. And I mean, 21 years of being widely used is a nice record. That said, however, it's just not designed for the modern hardware environment, and so...
Like I said, I think it's fantastic what you've
did
done. I'm
we
glad for it. I
made
just
a-
want to observe that the original made sense for its time.
Yeah, and I wish to tip my hat here to Andre Suri, who is our current manager and who was instrumental in getting us to give up some of our earlier architectural aspirations that we were still clinging to and adapt to a modern world. It's paid off. It was a good thing. I didn't like the idea that much at first, but he was right. I was wrong. Hi, Paul.
This is Vixie. I just want to amend the record in two ways. Jerry Scharf did most of the Bind 9 fundraising, and not I. And while Bob Halley's work was amazing, given the constraints, we got to remember that we had to dance with who brung us. The money came from hardware vendors. and they wanted it to work on their hardware, so that's why the assembly code was there, and so on. And also, Bind is 35 years old, not 21.
Dyne9 is 21 years old.
Hi, Patrick Feldstrom. Regarding the KSK role, it's a little bit messy to try to not use all of those external tools for DNSX, sign zone, and those kind of things, as long as one does not get information about when the KSK is rolling, when you're going to change that.
Yes.
So to be able to rip out all the other kind of crap that I've written myself that probably have a gazillions of bugs, can you not just have some kind of hook for like callback or look at Let's Encrypt? Unfortunately, they have sort of changed the way they do hooks like a gazillion times as well. So I understand that you don't want to do it like too many times. But
it's not there yet, but that's high priority. Some mechanism, either, I mean, it could be an RNDC command that you can look up and get the time and schedule something for yourself. It could be some call out to send email or whatever.
Yeah.
But yeah, at the point when you know when the next KSK role is coming, if you don't have the ability to broadcast your DS change to the parent automatically, there has to be something out of band that tells the operator to do the job. We don't have that yet, so it's, in that sense, not fully cooked. But it's worth looking at and playing with. He's done great work, Matthias says.
Please.
Hey, Eric Scrolla. I'm just curious, in the stack diagram you showed earlier, what are you going to do when you have to put quick in?
What's that?
What are you going to do when you have to put quick in?
I can't really answer that.
Okay.
I'm interested in looking into it, but I haven't researched it in great detail. I'm hoping that it would just be a matter of sticking another module in. But
yeah, I think it depends on whether or not you have a combined quick H2, H3 stack that has a common API or not. Because if it does, it's going to be a pain to have the modules parallel.
Mm-hmm.
So this is Unre ISC. To answer Robert's question about the assembly, there's still a yield in the RW log that's going away. There are still some little assembly left, and in the backtrace, there's one instruction. And as for the DNS-OARC quick, the libuv is callback based, and I expect we would just plug ng HTTP3 or whatever library is available at the moment to it, in the same way as we are going to plug ng HTTP2 for DOH. So it will be just another transport for us.
Okay, if there's no more questions, thanks, Evan.
Thank you very much.
So what is it, just the right-hand button? Right and left. Okay, that's easy enough. Hi, everyone. I'm Dan Mahoney from ISC. I've only shown up once on this stage before, and when I did, I shut down a production service. So I'm going to promise not to do that today. We'll start with this. I've been with ISC for 12 years working at the Bay Area most of the time. I've been working on FRoot for probably about 10. Brian Reed, who many, many people in this room know, retired in 2019. Ray Bellis, who you all know, has taken over DNS operations, or not DNS operations, but FRoot operations, and formerly held the role of senior research fellow. We also now have Elmar Binns over here in the red shirt. And this talk is really not going to be so much about the DNS protocol or anything like that. It's just we've been doing a lot of upgrades lately, and root operations tends to be a bit of a black box to a lot of people, and other than the people in this room who are other root operators. And I wanted to share some of the things we've learned in the hope that maybe the community can benefit from them, and maybe it demystifies things a bit. So this is a typical FRoot node at some data center. I don't remember which of our internal wiki pages we pulled this from, but if you know your hardware, it's 2 Cisco routers at the top, 2 Cisco switches, 3 servers of varying age that are generally, AMD 64, but fairly generic based. There's not always a good management plane, and very often it's been based on whatever we could get donated by the local sponsor, whatever somebody had in country, or whatever was available at the time. Out-of-band access here was almost always serial consoles, which is the best 1965 has to offer for us. Anytime we could get access to an actual KVM on the machine, it was some limited KVM that would pop up about a dozen. Are you sure you want to run Java? Are you really sure you want to run Java? Oh God, I have to break out my Windows XP VM to run this remote console machine. And when you have 50 nodes out there, forklift upgrading all those at once, even to a new OS, let alone new hardware, gets difficult. It's also 14U of machines in a data center that, you know, Netflix will deploy a 4U box that caches everything you're going to do. RIPE has a single box solution, and this is incredibly power hungry in the modern world. And hardware fails. So yeah, I covered this a little bit in the last slide. With Cisco routers, a lot of these were the Cisco 7000 series, 7200s, 7206VXRs, and 7201s. Even with the greatest hardware they have, they max out at 2 gigs of RAM. And when you're taking full routing tables from 2 peers, or 2 transit providers, and full peering from everyone on Exchange, that starts to get really tight really quickly. Every time you need to do a reinstall, it's hard. The only way you can get a reinstall done without an active KVM is to talk to someone and guide them through the FreeBSD installer, often when English isn't their primary language. And you'll get back a message of, hey, I think it works now, go ahead. Many exchanges are moving to 10 gig speeds, which there's no option to do that on Cisco's. And parts are getting older. RAM for these machines is getting older. If you blow a flash on a Cisco router, I recently had to buy a $50 piece of flash and attempt to spend $300 in customs to send it to South America with limited success. These are the problems you have. That is a giant pain in the neck when you're trying to upgrade things. And yes, a lot of people locally have provided these things to us and said, here you go, we've got these brand new machines for you. And they go to some other job, and the nature of the relationship is they've been your complete steward throughout the process, and then you get a corporate attitude of what have you done for us lately. It's well known to the community that we're working with a CDN. I can say the name, it's Cloudflare. That has been received with mixed results, and a big concern was, okay, they're just going to run FRoot, and that's it. And we absolutely are content to continue growing our network, to continue to be an absolutely core network provider, but overlapping with them. They tend to do larger installs, and it lets us focus on other locations where newer exchanges, smaller IXs, embedded sites, new ISPs who want that internal presence. So it actually lets us overlap well and focus on what we do well. We absolutely still run global FRoot nodes in partnership, and we work very closely with them. It's not that we handed over the keys to the kingdom and said, there you go, go. So the other thing we've discovered as a way of fixing the hardware problems we've had is there's a lot of terrible hardware on the market, and we've standardized on Dell. Dell they've shown a few new things recently. I mean, they've been on the market for 20 years, but their baseboard management controller is way smarter than anything else I've seen. If you're talking to a Dell BMC, you know the status of the voltage on every PSU you've got. You know the state of the fan on every machine you've got. You know what the state of your RAID card is. And when you've assembled a machine from commodity parts, which is what most of the other integrators are doing, you can't see that. It also means that if you're working with a vendor like Dell, people have told us to try HP, and we need to evaluate those as well. If there's a Intel speculative execution problem, or if there's a exploit in the ILOM, you're actually going to get updates. That will not be the case with Supermicro, for example, is very, very slow to come out with updates. You know, when you're 2 years out the door, good luck finding a BIOS update that fixes that. And Dell has a wonderful HTML5 remote console that lets us do everything. That means we never have to deal with Java again. And if you follow the licensing state of Java, they're now saying, oh, if you're going to use this in the enterprise at all, we want money from you. We want you to license this for us. So Java is free to do things that no sane person would do for an individual, but for corporate use, it actually becomes an interesting liability. So yeah, the cool things about the Dell iDRAC, and again, I'm not trying to sell any of their machines, but if I do, I'm okay with it, is I can get to their iDRAC via SSH, HTTPS, SNMPv3, all solid encrypted protocols. I can actually run one command that will cause an ISO to show up on the machine natively booting, even if it's not there. It can copy over from a Samba server, or I can do a browser mount. It's wonderful. I can actually install an OS completely via a screen session, SSH to the iDRAC, where I'll redirect the installer's serial console into my window into the iDRAC. And they have an SD card, which means I can keep a cache of bootable install tools sitting right there on the SD card on the machine. So it's a virtual crash cart sitting there. Anything I wanted to do with the BIOS that normally I'd have to screen share and page through BIOS screens, I can get there and do with one command in SSH. I reboot and I've reconfigured my memory optimization, or I've reconfigured my power utilization right there. This is useful. On the software side, I'm not going to talk about Dell for 20 minutes. That would get a little insane. The state of the software routing stack, back in the day, 10, 15 years ago, you had Bird. You might have had GateD or something like that, but those weren't full implementations. We used to use some variant of Quagga to signal to our upstream routers that the froot presence, or the froot prefix was present on the boxes, and it would advertise and withdraw those from the router. But now, since the box is the only thing that's present, we need a way to do that on box, where the box will take on the full routing information base and can actually update the fib on the machine. We're also, in previous iterations, the way we handled upgrades was Peter Lasher and a screen session. And Peter was really fast with SCP and didn't like to sleep a lot. Bless him, he's no longer with ISC. But we've discovered that tools that didn't exist 10 years ago, and even the term DevOps wasn't a thing 10 years ago, we've now gotten into Puppet utilization, where from the install point, it is one command to fully bring up a box with some minor monitoring to make sure it's doing sane things before we actually bring it live. So multi-fib support, I get this from a lot of people who don't do this. We have a system that's basically both a router and a service box. So it takes in a tiny routing table for, thank you, most of its management stuff only has a default route out to the world. It just needs to see, if I'm going to SSH into it, I don't need to know how to get back to corporate over the exchange that we're peering with. I just need to be able to see my way home. But bind needs to see everything. It needs to see, how do I get the packets to the fastest peer? So we've got one fib for management plane, one fib for service plane, and that's a fairly new feature in operating systems that didn't exist 10 years ago outside of very, very weird processes. I'm not reading my slides exactly, but you're welcome to grab them and read them. So I mentioned VAT earlier and what it takes to get things out, and what we've learned after dealing with a lot of vendors who have said, hey, we'll get you the box. We'll furnish the box for you if you just run it for us. Buying boxes and shipping them out all over the world is a great way to burn through money. It's also a great way to fully employ a person who does nothing but logistics, because no two countries have the same sane policy about mailing a box all over the world. So we simply supply a descriptive manifest that says, we want this box with this many processors, with this enterprise license for this, and a really good warranty, and we can run based on that. We usually tell people we want a dual 10 gig NIC for the obvious reasons that there are run lengths for how fast you can do with RJ45. And as more exchanges are moving up to 10 gig interfaces, we can do 1 gig over fiber on a 10 gig optic. We can't really do that. You know, we're not going to deploy a 1 gig fiber card. That's not even a thing you can buy anymore. But there's a growth problem with that because we need to reprovision a bunch of things. This box now has 2 transits needed. The exchange portions are different. So what we, myself, Ray Bellis, and Elmar are spending a lot of time doing is saying, yeah, we had 2 transits previously, and we announced a /24, but we now need to get 2 transit drops that actually have statically configured default routes so that we can reach our iDRAC. We need to do our filtering a little bit different. So that's what we're spending a lot of the time doing right now is grooming things into the new model. Obviously, when you change out hosts, there's different MAC addresses that need to be added. Exchanges need to be made aware of the process that they used to be peering with 2 routers, now they're peering with 1. It's been a lot of forklifting. I'll talk a bit about software. As far as I know, as long as we weren't on a DEC alpha, we've been using FreeBSD, whatever stable release we can run. We don't run head or current or anything like that. We run a stable bind. But with the iDRAC, we can actually come along and rebuild for the same platform on Linux. We can do a single-click deploy and get there, and Linux will come up and Puppet will come up, and that could be an option. We're not there yet, but that is one of the goals, even if we never need to use it. If there's a 0 day in the OS, or we just want to, experiment more in our labs, not in the public deploy. We do maintain our own FreeBSD package building architecture. This is useful because we run it in-house. There are features that will be seen on the root that we will need to build custom versions of bind that are not the default for whatever the packages that come with the OS are. Largely, we run with what the OS has, but it's an option that was important in the past, and it lets us build every package, not just the bind ones custom. I already covered a lot of this, but we're using Bird 2, as I'd mentioned. We wrote some scripts that take all of our old Cisco router configs that used to handle all our peerings. We'll demux the passwords so that any peers that already existed would come over. We continue to use a multiple AS per site. I think ISC is the only root operator that does this, although it's actually in some of the RFCs as the way to do Anycast. I didn't look and check which RFCs, but I remember a mention being made of it. Because when you're trying not to leak routes, when you're trying to keep local traffic local, the only thing you have in a looking glass is an AS path. You can't do a version.bind query. You can't do a dig. You can't do NSID. So the only way you have of telling what has leaked is the AS path. We have a number of health checks that actually operate on bind, where if they see that bind is behaving in some unresponsive way, or if it's not responding, it'll simply rip the froot prefix off of the loopback, which will cause the routing daemon to withdraw it from the routing table cleanly. So peers don't flap, they just don't see the route advertised anymore, which keeps our email addresses a little bit cleaner. Again, speaking to DevOps, we're using Puppet. I say in this slide that we use it more like most people use Ansible because we want to control tightly when those pushes happen. Our change delta is usually pretty low, so we don't want a daemon running every 30 minutes to do something until we're good and ready. So it's very, very push-centric, but the Puppet language has worked well for us. We're also using our Puppet manifests as a source of truth. So our monitoring will feed from Puppet. Our reporting will also feed from Puppet because if it's in there, it's a real thing. We're doing some pretty decent CI with Puppet that I mentioned here. Monitoring is the same things you'd expect, Cacti, NetDot, Nagios. There's nothing really to talk about here to this group. I put in here for completeness, but SNMP monitoring of the iDRAC lets us see every single piece of hardware we've got. If I blow a fan on this with commodity hardware in the past, I wouldn't have noticed that. I would have seen that the box is running a little hotter, but I can't see the state of fan number 3 unless I've written a check for that specific box that was deployed to that site. And there are tools written for Dells because of the wide install base that let us go, oh, here's a MIB that tells us everything. Ray, I think, presented previously at some of the things he's doing with RSAC stats that let us detect when a route is leaking. That, for example, our Los Angeles node a few weeks ago, because of a misconfigured peer, was being seen all over the world, and it was lowering our global latency, or raising our global latency, I'm sorry. You know, we were able to fix it. We contacted the peer. They said, oh, whoops, we configured you in the wrong mode. We fixed it. We're trying to script that a little bit more, but it is a bit of a manual process there. And then future work. We peer heavily. We have probably, I would guess, I should have had this number ready. We have close to 1,000 peering sessions, I think. Would you say that's right? Like 300? Huh? That has been as last 3,000. Okay, so I'm off by an order of magnitude. That's great. Maintaining this is complicated. It used to be that we had to log into Cisco routers and type neighbor, BGP, foo, and it was easily a full-time job for one person, possibly two. It's a junior job, but it's constant as peers gain and leave exchanges and as peers arrive. We're automating that more. We're trying to make it so that if you see us advertised on a peering exchange, you can connect to us. We'll look up your info on PeeringDB. We'll send you a, hey, here's the FROOT policy. Click OK. And suddenly you'll get prefixes. We're trying to be a little bit careful that it's a thing that you are aware of without it being an agreement, that you know, there's no legal contract there because we peer openly. Just a case of, hey, just so you know, this is going to give you DNS. We're trying to do smarter filtering. That may be a future DNS-OARCs where we'll talk about that. And I've talked with a few of the route views collector people and seeing, hey, we have a really big routing table. Are you interested in that? What I've gotten so far is just cursory interest, but because we have a scriptable daemon on most of our deploy, there's a possibility. We also have rolled out our PKI. We don't want to be the first root operator to do it, but we don't want to be the last. But we've tried it on our internal networks. It's working. It's doing the right things, but we're not going to apply it to F first thing either. So that's it. We want to hear from you. If you think there's things we could be doing better, great. If you want to continue to work with us, if you are a local ISP or a local IXP, come find us. We are trying to get these older boxes out everywhere. I would like to never have to walk somebody through the BSD installer again. I think that's it. I think I have time for questions.
Thank you very much. All right. Yes, I'm Brantly Millegan. I'm from the Project Ethereum name service. We just joined as a blue member of DNS-OARC. So Keith, thank you very much for having us and for letting me speak here. Really appreciate it. I actually work for a nonprofit organization called True Names Limited. We're a Singapore-based nonprofit. And we're just sort of like the de facto managers of the open source project, the Ethereum name service. So we don't own it. The code is all public. In fact, we have many people outside of our organization who contribute to it. We're very much kind of a community project. The team that's kind of employed is very small. We just kind of help to manage it. Our lead developer is Nick Johnson. He lives in New Zealand. I don't know if there's any Kiwis here. He's like very proud of this. And our initial patron has been the Ethereum Foundation. That's where we get most of our money. So here's just an outline. I'm going to kind of do a big picture, then kind of a more technical picture, and then talk about how we're integrating with DNS. So what is ENS? This is one description. I actually think I would use the word complementary rather than alternative. We're a complementary internet naming infrastructure with all the security, censorship resistance, and programmability of the public Ethereum blockchain. And what are our goals? Like, why am I here? Okay, so short term, we want to complement the DNS tech stack in parallel. We don't need to touch it in any way. And we want to expand the capabilities of the existing DNS namespace. So this is not an alternative root project. It's nothing like that. Long term, we think that something like our technology could actually just kind of eventually become the tech stack for DNS. I know many of you here probably think that's ridiculous. Maybe it is. If that ever happens, I don't expect it to happen anytime soon. But that's sort of where we're thinking. It also informs how we are building it and how we are structuring ourselves. We're in this for the long haul. We're thinking this is a project that's going to exist and evolve over decades. So that informs how we're setting this up. Our philosophy, we think blockchain technology it's more interesting in how it allows for better infrastructure than for the creating of an alternative root. You could do that without blockchain technology. Blockchain technology doesn't make that easier or harder. We support ICP3, if you're familiar with that document. We do have one ENS native top-level domain .eth, which is really for experimentations with the full benefits of our technology, which ICP3 in Section 5 allows for. But most of the namespace that works on our system is the current DNS namespace, and we're not looking to compete with that or that ICANN process. We already have .xyz, .lux, .cred, .art, and .club integrated, and I'll talk more about that in a second. And actually, pretty soon, in the next few months, we'll roll this out to the entire DNS namespace, or at least all of it that has DNSSEC enabled. As was mentioned earlier today, that's not all TLDs, but it's most of them. I think it's around 1,300. Like I mentioned, we're an open source, nonprofit, community-driven organization. There's literally no way to invest in this project. We didn't do an ICO, if you know what that is. We don't have a special token. We run on the already existing Ethereum blockchain. We use the ETH token, which is just the native token to that blockchain. And we're supported by the Ethereum Foundation. So what can you do with ENS? So first, I'm going to talk about it from kind of a use case standpoint. Ultimately, with any naming system, like with any naming system, you could do anything. You could store any information. But sort of the concrete use cases that we have right now, one name for all of your cryptocurrencies. If you're familiar with cryptocurrency, there's a naming problem, and we help to solve that. Usernames for dApps, or decentralized applications. Decentralized websites. We actually have a partnership with Protocol Labs, the managers of IPFS, and this duo of protocols, ENS and IPFS, is sort of what we're calling the decentralized web. That has a number of integrations. We think we solved the Tor.onion naming problem. Some Tor people might be skeptical of that, but I'd love to have that conversation. We think we've solved it. We also just have text records for any arbitrary information, and we also support DNS records, and I'll talk about that more in a second. Here's a little bit about our ecosystem. The things that probably would interest you guys the most, we have native integration in Opera, as well as some mobile browsers. We're in also the most used browser extension for interacting with Ethereum dApps. So that would be would work in all the major browsers. We were offered an ICANN research project by David Conrad. Some of that's still in process, but we're excited about that. Truffle Suite is just it's a development platform. And we have this DNS records project with .cred I'll talk about. So now in terms of kind of like the specs, how does ENS compare to DNS? So number one, simpler infrastructure. The whole hierarchical server system, we don't have that. We're just a set of smart contracts on Ethereum, much simpler. By definition, we can't have downtime based on depending on how you're accessing it. We have built-in cryptography and individual ownership right from the beginning. I know there's been lots of talk about DNSSEC adoption today. And the last two are particularly interesting to me. ENS allows for names to be programmable and to interact with other Ethereum smart contracts. I'm not going to say much more about that, but I think that's particularly interesting. Okay, so how does ENS work? A few words just about blockchain technology in general. What is a blockchain, kind of at a basic level? It's a shared database that users can change only under certain specific conditions. These conditions are enforced by a wide range of things: cryptography, proof of work, proof of stake, the ability to fork, the existence of thousands of copies. I won't go into this. And anybody can run a node that has the whole database. Why is it called a blockchain? Well, because this database is updated in batches called blocks, and that block is cryptographically connected to the block before it, and you have a chain of blocks. So it's a blockchain. And accounts are public-private key pairs. That's built in. You probably have heard of Bitcoin. It was the first blockchain. It's just trying to be like a peer-to-peer cash system. It may or may not succeed that. But Ethereum is a DApp platform. It's much wider in its what it's trying to do. So how does ENS work? As I mentioned, we don't run any servers. It's entirely a set of smart contracts on Ethereum. You don't need permission to interact with our system. How do you make a change? You have to submit a certain kind or set of Ethereum transactions. This, of course, requires having an Ethereum wallet, and it costs ETH. Even if you're not sending value, doing a transaction, you have to pay a network fee in ETH. This is a limiting mechanism to prevent spam. So for example, if you wanted to register a .eth name, it's a two-transaction process, one to initiate it and then another to finalize. And this is to prevent a certain front-running attack with miners. How do lookups work? So lookups, of course, are free because you're just reading from the Ethereum blockchain. It doesn't cost anything. So how do you do this? You have to have access to an Ethereum full node. So this could be running locally on your own computer. So on my laptop, I run an Ethereum full node. So if I'm interacting with ENS, my client is grabbing that information from the full node on my computer. It's not going elsewhere at all. If you're not running a full node, then you'd have to use a service. Cloudflare has a service looking up things on the Ethereum blockchain, as does another company, Infura. This is how a lookup works. So it's a two-step process. You, go to the ENS registry contract on the Ethereum blockchain, and you say, I have this name. Where do I find the records? You get that the address of where the records are on the blockchain, and then you go look up the records. And this allows for custom record sets. You can have any type of records you want. This is the record set that we maintain, which we call the public resolver. We have records types for cryptocurrency addresses. We have a content record type for IPFS hashes, swarm hashes. That's another distributed file storage network similar to IPFS. Also, it supports Tor.NN. We have text records for any arbitrary records, and then DNS records as well. So there's two types of integration we have with DNS. The first is DNS namespace integration, and the second is storing and serving DNS records with ENS. So namespace integration. So what does this mean? Our goal with this is that people can make ENS records for DNS domains they already own through the normal DNS registration system. So if I have example.com, I have a DNS record for that, but I could also, in parallel, have an ENS record for it. Not example.eth. This kind of confuses a lot of people. .eth is its own separate TLD and namespace. We're talking about example.com being on ENS. So for example, I own Brantly.xyz. I have that on DNS. If you go to that, I have a website. But I also have that on ENS, and you could send me, Dogecoin or something if you wanted to. So how does this work? How are we accomplishing this? It's a two-step process. So number one, you just have to prove ownership of the name to an Ethereum smart contract, which I'll explain. And then you just create and manage the ENS record like you would any ENS name. So I'll explain this. So we have a DNS-SEC oracle on Ethereum with the DNS root public key. And this can verify any DNS records. I actually think this is really interesting. This could have a lot of use cases beyond what we're using it for. Anybody can use this. We're just using it for a specific use case here. It also saves proofs already submitted. So this cuts down on costs over time because certain so it doesn't have to redo certain verifications. The way it works is that you create a subdomain for your, on the second level domain that you want to claim. So let's say _ens.example.tld. You have to have at least one text record that has A equals and then the Ethereum address of the wallet that will control that name on ENS. Ed Lewis, as previously he mentioned earlier about not using text records, getting your own RR type, is something that we have considered and would look into, but right now we're just using text records to get started here. So this is what it would look like. So you submit this proof to the DNS-OARC oracle on Ethereum as an Ethereum transaction. And if the proof succeeds, the smart contract automatically grants ownership of the domain to the Ethereum address provided in the text records. That's how it works. A note on this, you can always redo this proof. So if on Ethereum you own a DNS name on ENS, if you pass control of that, let's say to another Ethereum account, let's say to another person, you can always redo the DNS-SEC proof and kind of claim it back to whoever owns the DNS version of it. So ownership always follows the DNS side for DNS names. There's no registration fees for anything like this. It's totally free. This is unlike .eth names, which do have an annual fee as a anti-spam measure, or I'm sorry, anti-squatting measure. This is since you've already paid fees. It just kind of expands the usefulness of the names you already have. And all of this is done, of course, by interacting with the smart contracts on Ethereum. And we have a manager UI that can help you to do this. But of course, you can do this without our UI if you want. And this works right now with .xyz, as I mentioned. So like I mentioned, I have Brantly.xyz with DNS. I have a website. And then this is what my ENS records look like for Brantly.xyz as well. So that's integration at the second level domain level. We also have integration possible at the top level domain level as well. So both ENS and DNS, of course, work hierarchically. So if a top level domain owner wanted to claim their top level domain on ENS, that would, of course, give them control of that entire namespace on ENS, which they could have match up to the namespace on DNS or not. They could do with it whatever they'd like to. And this is also possible. .lux has this exact type of integration. They've had it for about a year now. Also, this is the type of integration that .art, .cred, and .club have. And that allows them to do some special things. Those are not normal top-level domains. These are newer GTLDs that do have customer-facing businesses, so they can offer special services as a result. Why would they do this? They can make the process easier for customers to claim their ENS record, to add this extra functionality to their name. They can manage their namespace. They can use it for a special project like .art is using it to store records of ownership and the chain of ownership of art pieces. .cred, which I'll mention here in a second, is also doing something interesting. So, what do I think top-level domain owners should do? Basically nothing, except just make sure that DNS-SEC is enabled for your top-level domain, which you should have anyway. If you don't do anything, just with our system, it'll be possible for second-level domain owners to claim their name directly. And we would only recommend you try to claim your top-level domain if you have like a good reason to do so. Otherwise, there's nothing you need to do. Okay, so the second thing with ENS and DNS is DNS records on ENS. So this is more kind of at the experimental stage. This is very early. We have a pilot program that actually just launched. I don't have as much information here in the slides because this just kind of, I wasn't sure what the state of it would be as of this conference. So .cred, which is a closed top-level domain, they've claimed their top-level domain on ENS. And they've done a couple interesting things. One, they've made a special token on Ethereum, and whoever has that token on Ethereum controls the ENS version of it, but can also control the DNS version of it. So you can actually sign into their registrar with your Ethereum account, which means that you can trade the name with all the transactional capabilities and benefits on Ethereum, trading a token. So it's like instant. You can have escrow very easily. But you also get the benefits of the DNS name. I think this is very interesting, very innovative. But they're also using ENS for their DNS records. So they use ENS for the naming logic, and then they leverage IPFS, which is a distributed file storage network, for storage. And the bridge they use between these two systems is a project that we call ETHDNS, which is managed by a guy, Jim McDonald. It's a core DNS server with a special plugin that we've designed that basically allows it to connect and interact with ENS and IPFS. I'll just mention here briefly, ETHDNS also has the capability of running another type of bridge. So for .eth names, you can store IPFS hashes in the records and display those as websites in Opera and in certain browsers or through an extension. If you don't have an extension or one of those special browsers, we own eth.link in DNS, and we've set up this server there. And if you have your name .eth and you just add .link to the end, it will load like a normal website. So if you put in like Brantly.eth.link, you can load it like a normal website via ETHDNS. So we also have that as a bridge. So what are the benefits to this? I'll just mention briefly. We think there's better security. Users can verify records. You can have individual management of the records. That's a whole rabbit hole topic. And also less hardware requirements for the DNS provider, depending on how this is accomplished. Right now, we wouldn't recommend that somebody, depends on this exclusively, so we would recommend running things in parallel, but eventually it could have that effect. This is very early. This just launched like in the last couple of weeks. So that's the end of my presentation. Thank you very much. Does anybody have any questions? I'm assuming some people do. Hello.
I have one question. That's why. So you describe a technology, but you didn't describe any use case. So after listening to you, I really don't know why I would do this. So because what is the use case? What do I gain? Well, you showed like better security, but what does it mean? So what is the benefit of doing all of this, except for putting DNS on blockchain?
Right. So thank you for that question. I think I was going quickly. I did have a slide comparing having advantages. So there's whole types of things that you can do with a smart contract, Ethereum-based name service that you can't do with DNS, such as programmability, interactivity with other smart contracts. It also makes them easier to manage, to pass between people. You can have self-custody, individual ownership of the name, which isn't possible. That provides censorship-resistant benefits. I think there's robustness benefits. You can have the data securely on your own machine. So I think there's many benefits that I actually did mention earlier in the presentation. I'm sorry if I went quickly on that.
Hi,
Yes.
Glenn Dean, Comcast. So I'm a little confused about this a little bit. So I get the blockchain, I get the technology. You're, through your contracts and through Ethereum, establishing an alternate route of who owns what in the DNS. And doesn't it create a conflict then with the TLD? So for instance, if example.com, let's talk about example.com. So let's say example.com is owned by me today, and then I do something bad, and .com says, no, you lose example.com, I'm giving it to law enforcement because they've seized the domain. That's what takes place today in .com, but your system, what would it do in that case? Would it follow that same transaction chain? Or we kind of go, no, we don't recognize that law enforcement authority, we're still going to have it owned by Glenn. What happens?
Good question. So again, I think I went through this quickly. Whoever owns the DNS version of a name owns the ENS version of the name, because you can always do a new DNSSEC proof to claim it back. So the chain of ownership always follows the DNS side.
So whoever owns it, okay.
But that is not automatic.
Correct. So it has to be done.
That means that even if the domain expires, I still own it on the ENS.
Correct. So it has to. You have to do that. So like a registrar could do that automatically as a service, but you're right. So the Ethereum world doesn't know automatically what's happening in the DNS world, but it just requires submitting the transaction and it's done. But you're right. It doesn't happen automatically.
And it only works on DNS-SEC signed domains?
So you can only integrate into ENS names that have DNSSEC, because that's how we prove ownership.
Okay,
of the
so it's sort of like a sparse DNS thing, because anything that's covered is in, but anything that isn't covered is out. Okay.
Correct.
Interesting.
So this
still
actually
got some holes, I think.
I'm sorry?
It's interesting, but I think you've still got some holes.
What are the holes?
These short sessions are too long to. Yeah.
Okay. Well, thank you. We're here to have conversation, dialogue. So that's what we're here to do. Thank you.
Paul Hoffman. Hi again. Your presentation's getting better each time, so
thank
glad
you.
about
You've
that.
heard this before?
Yes.
Oh, where?
Well, at the ICANN meeting.
Oh, in Marrakesh.
Right.
Yep.
Yeah. So, however, I still have the same issue that I think other people here might have, which is the scalability. Somehow we've made the DNS scale, time-wise, over the last 30 years, 40 years. However, and right now, like you said, you have a copy of the Ethereum blockchain on your laptop, so you can refer to it.
Correct.
At some point, if you're very successful, that will be harder. And as the Bitcoin world has discovered, you have to have super owners and such like that, because you can't, even if you could hold the blockchain on your laptop, the terabytes of moving in and out. So it feels a little bit odd to me for someone to rely on this, because they would, in fact, hope that you're successful, but as you get more successful, it will be harder to do lookups. And I don't know if, I haven't seen anything where you've looked at possibly forking so that lookups are still at the same speed that you want, but then you're sort of outside the Ethereum blockchain. And I don't know if that's appropriate here to talk about, but we, over time here in the DNS world, have looked at, oh my God, what happens if we get really successful? How do we keep lookups going quickly? And I have a concern about that with ENS.
Yeah, no, great question. So scalability is a problem for blockchains in general. So here's sort of our thinking about that. One, we want to remain on the Ethereum blockchain because there's lots of benefits from interactivity on that. Right now, it's obviously not a problem. Everything works fine. But if we, say, as we grow and if we became very successful, there's numerous paths to scalability. There's layer 2 off-chain solutions that exist now and that people are also working on that we could leverage. There's also fundamental Ethereum protocol scalability things that are in the works. So sharding is one example that could massively scale Ethereum without us having to go off-chain. So there's multiple paths that we think we'll cross that bridge as we move along. Right now it's not a problem, but there's multiple ways that we could today scale if we needed to, and there's also multiple ways in the works that we would expect to help us to scale.
Hi, Jacques Latour with Syrah. It's the second time I see this. I'll be honest, I don't
also
get it.
Also from Marrakesh?
Yeah, and before I think also at ICANN meetings. I don't get it, but is the driver for you, there's a transaction cost. Somebody makes money somewhere? Is that the driver for you to do this, the money?
Do I make money if you use DNS?
Somebody makes money.
I don't make money if you use DNS.
So I don't get it, sorry.
Okay. It's open source software. There's many incentives that people have to work on open source software. I think most of DNS works on open source software. So, I don't think any of us become millionaires the more the DNS is used necessarily.
I think to clarify his question, you said there's a transaction cost. Who receives the transaction cost?
Oh, okay, yeah. So this is just basic on how the Ethereum blockchain works. So when you submit any transaction, as a limiting factor, there's a transaction fee. This solves the halting problem. And that goes to miners which validate the chain. So that has nothing to do with ENS as a protocol. That's the Ethereum protocol. Good question.
So your documentation says you're using TXT records, but I know you did apply for an ETH record that was initially rejected. Are you planning to reapply for that?
That's a good question. Yeah, so a few months ago, we did put an application for an ETH record, and it was sent back just saying that we had like the wrong formatting or something like this. We had never done this before. It lacked certain things in the specification.
It lacks any specification.
Okay, I mean, did you see it? Were you part of it?
I was one of the reviewers.
Okay, perfect. So we never done this before. It's still something that we'd like to do eventually, possibly, but you know, it's ongoing.
Okay, thank you.
Hey, this is Jan, NS1. I'm wondering, the lookup operation is also transaction in this model?
No, it's not, because it's just a read from the blockchain. So you could not, you know, most users don't run their own full node, but if you were, you're just simply reading off of your computer, or you're reading off of somebody else's computer, but there's no, you only pay a transaction fee on the Ethereum blockchain if you're changing the Ethereum state, and you're not changing the state. So it doesn't, you can have unlimited lookups for free.
Okay, and is it possible to like enumerate these changes, like for a particular name, for instance? Can I like get a history?
Of the changes? Yes.
Okay, because yeah, I'm trying
that's all saved, yes.
I'm trying to find some use case that might be useful for DNS, and in DNS we, for instance, have trouble with like something like certificate transparency. We don't know if someone owning a key like forged one response, signed it correctly, and send it somewhere. So maybe this would solve the problem, like
Perfect.
this particular problem. But
there you go. It's extremely useful. There you go, everybody.
Wes Herdeker, ISI. Let me see if I can help you out. So I'd love to see this again, actually. And I think
Great.
I've seen it twice now, too. But I think the biggest missing thing that I think most people in this room are missing is that they don't understand the smart contract side of Ethereum. So the benefits derived with having a handle in the ENS and in Ethereum are sort of lost on a lot of us. And I know only this much about smart contracts, where I really need to know a whole lot more. And so it'd be great to have a couple of slides of, now that I'm registered, these are the things that I can do. And here's a walkthrough example that allows me to use a smart contract that I couldn't do with a regular DNS name. And I think if you had that on there, your pitch would be much more understood by the audience.
Great.
I think overall, I think the technology is cool. I like how it's transpired.
He thinks it's cool, guys.
Yeah.
Thank you.
And sending money is sort of an example. You sort of threw that in there as a very quick bullet. But I think overall it's a good technology. I have the same concerns about scalability and long term how you're going to deal with that. But.
Yeah, I mean, I agree. We're aware of it. I think scalability is sort of always a problem, and we have multiple paths that we could. We haven't like currently solved the problem, but I think it seems doable.
This is Ole from .se. So personally, I think this is one of the most interesting things that's happening in the DNS world.
Thank you.
So
there we go. Amazing.
But professionally speaking, I have one criticism of this, and this is exactly the ownership of names. So in case a domain expires, there's actually no way to retract that name from the chain, because only the owner can do that, right?
I guess, what do you mean by that?
Yeah, let's say example.com would expire.
Oh, if a .com expired, could it be?
What happens on chain? And of course, the chain doesn't do anything automatically. But nobody can retract the name, except for the owner of the name, who would say, "Oh, I don't want to own it any longer." But it basically stays with the owner. Not even a TLD, not even VeriSign as the owner of .com could retract the name.
Well, it's if somebody would have to. Forgive some of my ignorance about exactly how registrars work, but somebody would have to submit just another DNS-SEC proof. That's all that needs to happen.
But you can't if the domain isn't in the DNS.
Right. So this would have to be, this could be a service that registrars provide as something's.
And the registrar can't do that.
Well, maybe as it's like expiring, or the next person could do it. But you're right. I mean, there is some ambiguity of what would happen here. But I think it's a solvable problem.
Yep.
So like what would never happen is that one person, let's say, has example.com on DNS, claims the ENS, and then someone else gets example.com on DNS and like can't get the ENS version of it. Like that would never happen. They can always claim it.
But they would have to do something actively.
Correct. Yes. They do have to do so.
That is my criticism.
Right.
They have to do something actively. If they don't know about DNS.
No, you're right. So one group that we've had a lot of conversations with is registrars to try to automate this process just in general. So like something I would love to see in consumer-facing registrars is if you have a name, they just automatically give you the ENS record for it. But you're right. I mean, most users are not, it's difficult to do. They're not going to do it.
But you're relying on a third party doing something for everyone.
Maybe I should talk to registries then. I guess I thought it was like a customer-facing like product thing, is I guess the way I've thought about it, but maybe it's more of a registry thing.
Okay.
That's good to know. Thank you.
Hi, Eric Scrolla. I'm just trying to understand the extent of the vision here. You know, I have my DNSSEC name, as you say, and then I get my corresponding ENS record. Are you expecting that? What are you expecting sits in the blockchain? Are you expecting the A records and the quad A records? Or expecting NS records? What are you expecting?
Good question. The primary use cases we're sort of encouraging for people with ENS are things that DNS doesn't already do. So this would be things like cryptocurrency addresses is like our biggest use case. So you could store your Ethereum address, your Bitcoin address, your Litecoin address, all those things. That's our biggest use. So you could store that. You could also store an IPFS hash, a Tor.onion address. You could do DNS records, although we don't really have any infrastructure support. That's very early. But those, what I already mentioned, would be the main use cases.
Right. I guess at the beginning, you sort of argued that this is censorship resistant. And for that, presumably, you'd want to not, I mean, presumably that seems unfortunate if you can't have the regular DNS infrastructure affiliated with that, right?
I'm sorry. Can you
so if this is censorship resistant, right, then you know I presumably don't want to have to like buy into IPFS and Tor in order to have my data hosted around, right?
So ENS is not stored on IPFS or Tor.
No, I understand, but my point is, if the thing that you when you get down to it at the end of it and what's in the record, right? If what's in the record isn't like accessible via the ordinary internet mechanisms, right? Then I've had to do more than buy into ENS. I've had to buy into Tor, Onion, or IPFS in order to store my data. When like what I really want is just a censorship-proof website, and so
you can do all that without interacting with Tor or anything.
Right, because you're anticipating. That's what I'm asking: is what are you anticipating storing? You're anticipating storing an A record or a quad A record?
I anticipate people storing. We don't call them A records. We just call them like a cryptocurrency record.
Sure, I understand. But my point is like I start with like example.com, and at the end of the day, I want an IP address that I can connect to, right? And I don't want like a Tor onion because it's like a pain in the ass, right? So I'm trying to figure out how like the chain of events that gets me there. And if the chain of events that gets me there is in your view, it's that at the end of the day there'll be an IP address stuffed in the blockchain.
Oh, I mean, eventually that could be the case. Yeah, I mean, you could ultimately store any information you want. Like right now, I wouldn't recommend using ENS to store IP addresses because we just don't have the infrastructure for that. But it'd be these other types of information, these other identifiers that you would right now. But eventually, of course, yeah, you could store IP addresses or anything.
Sure, I guess that's what I'm trying to drill down to is that you know, we heard earlier some talk about stupid DNS tricks and ECS, and people don't like it's not DNS isn't really a static database, right? And so I'm trying to figure out how you. How much the functionality of DNS is actually replicable via a mechanism like this, and how much is not replicable?
I mean, so you can obviously always change your ENS records. Changing them, if you're doing it on-chain, is harder than changing a DNS database.
No, right, but it's not a matter of changing them. It's a matter of different people get different answers. It's a matter of it's not like DNS isn't like it's like not like a globally consistent store in the way the blockchain is. So like if I'm doing a resolution of example.com, I might get a different answer if I'm coming from Canada or from Europe. And
So you're saying, oh, can you do that on ENS? Is that
I'm trying to figure out I'm trying to figure out what the whole system looks like. Yeah.
Yeah, I mean, you could. There's a whole area of different types of resolvers that we haven't developed a huge amount, but you could give different answers and things like this. Yeah.
By doing what? By publishing like a program that tells you.
You could label it. You could have it point to a smart contract that generates something based on information that you give it. I would say that's an area that's not very well developed right now with ENS, but that we have thought about and we just haven't done.
Thank you.
Yeah, thank you. All right, I think that's time.